As our world grapples with the challenges of global warming and climate change, an intriguing and seemingly paradoxical idea has emerged in some scientific circles: the prediction of a new ice age on the horizon. This controversial notion is based on a fascinating concept known as the Milankovitch cycles, a set of astronomical phenomena that have played a crucial role in shaping Earth's climate over geological timescales. In this video, we will delve into the Milankovitch cycles, their significance, and explore the debate surrounding the prediction of a new ice age. Understanding Milankovitch cycles. Milankovitch cycles are a set of astronomical phenomena that exert a profound influence on the Earth's climate over long periods. Named after the Serbian mathematician and astronomer Milutin Milankovitch, who meticulously studied them in the early 20th century, these cycles comprise three key components: eccentricity, obliquity, axial tilt, and precession, wobbling motion of the Earth's axis. Eccentricity refers to changes in the Earth's orbit from more circular to more elliptical over time, occurring in cycles of around 100,000, 413,000, and 2.4 million years. Obliquity describes the variation in the angle of the Earth's axis concerning the plane of its orbit, with a cycle of approximately 41,000 years, while precession completes one cycle roughly every 26,000 years. These cycles impact the Earth's climate by influencing the distribution and intensity of solar radiation received by our planet, playing a crucial role in triggering ice ages or interglacial periods. While Milankovitch cycles are instrumental in shaping Earth's long-term climate changes, it is vital to recognize that they are not the sole driver of climate variability. Today, human-induced global warming, primarily due to greenhouse gas emissions, surpasses the natural impact of Milankovitch cycles. Understanding these cycles helps scientists grasp past climate variations and offers valuable insights into future climate changes. However, addressing human-induced climate change remains a pressing priority to mitigate potential impacts on our planet's climate and ecosystems. Impact on climate. The impact of Milankovitch cycles on the Earth's climate is a fascinating and critical aspect of understanding the planet's long-term climatic variations. These astronomical phenomena, consisting of eccentricity, obliquity, and precession, influence the amount and distribution of solar radiation received by the Earth. The changes in Earth's orbit and axial tilt brought about by these cycles result in significant alterations in the Earth's climate over tens to hundreds of thousands of years. Eccentricity, which causes variations in the shape of the Earth's orbit, occurs in cycles of varying lengths. When the orbit becomes more elliptical, the Earth receives varying amounts of solar radiation at different points in its orbit, affecting seasonal and latitudinal climate patterns. These changes can trigger shifts between ice ages and interglacial periods. Obliquity, or the axial tilt of the Earth, determines the extent of the seasons experienced in each hemisphere. A higher tilt results in more extreme seasons, while a lower tilt leads to milder variations. These changes have a direct impact on regional temperatures and precipitation patterns, influencing the formation and melting of ice sheets. Precession, the wobbling motion of the Earth's axis, determines the position of the Earth in its orbit at specific times of the year. This motion alters the timing of the seasons, affecting the distribution of solar radiation throughout the year. Collectively, the Milankovitch cycles play a significant role in initiating glacial and interglacial periods. During times of low eccentricity, low obliquity, and specific precession phases, the Earth tends to experience colder temperatures, leading to the growth of glaciers and ice sheets. Conversely, when the cycles are in their opposite phases, the Earth experiences milder conditions, leading to ice melt and warmer temperatures. The prediction of a new ice age. Some researchers and media outlets have seized upon these cycles to make sensational predictions of an impending new ice age. The prediction of a new ice age has been a subject of controversy and debate among scientists and the media. Some have extrapolated the concept of Milankovitch cycles and suggested that the current combination of low eccentricity and low obliquity, coupled with a specific phase of precession, could potentially trigger a cooling trend leading to a new ice age. The idea is based on the understanding that these cycles have historically played a role in initiating glacial periods in the Earth's past. During these periods, extensive ice sheets covered large portions of the planet's surface. Proponents of this prediction argue that the current conditions align with those seen in previous ice ages. However, it is crucial to recognize the limitations of such predictions. While Milankovitch cycles do indeed influence long-term climate variations, they are just one piece of the complex puzzle that shapes the Earth's climate. The cycles are gradual and operate on timescales of tens to hundreds of thousands of years, far longer than the rapid changes observed in recent decades due to human-induced global warming. The overwhelming consensus among climate scientists is that the current warming trend is primarily driven by human activities, particularly the emission of greenhouse gases from the burning of fossil fuels and deforestation. These human-induced emissions have intensified the greenhouse effect, trapping heat in the atmosphere and leading to rising global temperatures. The predictions of a new ice age have been widely criticized within the scientific community for overlooking the dominant influence of human activities on our climate today. The Intergovernmental Panel on Climate Change, IPCC, and other reputable scientific organizations maintain that the urgent priority is to address human-induced climate change and mitigate its impacts rather than anticipating a new ice age. Debunking the ice age predictions. The majority of climate scientists and experts dismiss the predictions of a new ice age in the foreseeable future. They argue that human-induced global warming is currently the dominant factor shaping Earth's climate. The emissions of carbon dioxide and other greenhouse gases have led to a greenhouse effect, trapping heat in the atmosphere and causing temperatures to rise. The Intergovernmental Panel on Climate Change, IPCC, and other reputable scientific organizations emphasize the urgent need to mitigate climate change through collective efforts to reduce greenhouse gas emissions, transition to renewable energy sources, and adopt sustainable practices. In conclusion, the idea of a new ice age predicted by Milankovitch cycles is a captivating hypothesis rooted in the astronomical principles that govern our planet's climate. While these cycles have undoubtedly played a crucial role in shaping Earth's climate over geological timescales, they do not overshadow the profound impact of human-induced global warming. Our focus should remain on addressing the urgent challenges posed by climate change through science-based policies, international cooperation, and individual actions to safeguard our planet for future generations. If you enjoyed this video, make sure to subscribe to our channel for more content.